Hello everyone, we are Team Fantastic Four and our topic is Floyd Warshall Algorithm. The main aim of this algorithm is to find the shortest distance from each node to other node. For example, in this figure, let's take the node 1. So we need to find the shortest distance from node 1 to 2, node 1 to 3 and node 1 to 4. And again, we need to find the shortest distance from node 2 to 1, from node 2 to 3, and from node 2 to node 4. Same way, we need to find the shortest distance from node 3 to 1, node 3 to 2, and node 3 to 4, and again from node 4 to 1, node 4 to 2, and node 4 to 3. So, the main aim of this algorithm is to find the shortest distance from 1 to other node, 2 to other node, 3 to other node, and 4 to other node. If there are suppose let's say 5 nodes, so we need to go up to node 5 and we need to solve this n number of times. Basically, my point is we need to solve this n number of times. Or one of the way to solve this problem is using Dijkstra's algorithm. Let's forget about Floyd Warshall algorithm for now, and if we use Dijkstra's algorithm, then we need to use it for each condition. So we need to use Dijkstra's algorithm 4 times, right? But if we use Floyd Warshall algorithm, we can use it 1 time and we can store the value. So this Floyd Warshall algorithm uses the dynamic approach. It generates the result at once. Within one algorithm, it generates the solution and we can store that solution and we can use it every time. So it does not need to process every time, right? That is the main concept of dynamic approach. So now, when we use Dijkstra's algorithm, for each time our complexity is n squared, right? But in this case we are using it n number of times. For this case, 4 number of times. So our complexity becomes n squared times n. So our time complexity is n cube, big O n cube, right? So we can solve this problem using Dijkstra's algorithm, but we need to use that algorithm 4 times in this case. And to generalize, we need to use this algorithm n number of times. Talking about Floyd Warshall algorithm, unlike Dijkstra's algorithm, we can use it just once and get the solution, and we can store the solution for the dynamic approach, right? So now let's see the graph. So we need to calculate shortest distance from 1 to 2, 1 to 3, 1 to 4, right? So from 1 to, there might be many paths from 1 to 2, right? We can go to 3 and we can go to 2. This path might be shorter than the direct path, right? So we need to see each and every possibility. So to solve the Floyd Warshall algorithm, we need to create the distance matrices. So you might ask how many distance matrices we need to create. The answer is n plus 1, while n is the number of nodes. So in this case, we need to create 4 plus 1 equals to 5 distance matrices. Those 5 distance matrices are D0 to D4. So ranging from D0, D1, D2, D3 and D4. So we need to create 5 distance matrices. So firstly, let's see the D0. D0 is the initial base matrix. So the distance are just generated from the graph. From 1 to 1 the distance is 0, from 2 to 2 the distance is 0, and likewise from 3 to 3 and 3 to 4, 4 to 4. And from 2 to 1 the distance is 6. From 2 to 1 the distance is 6, right? It is the directed graph. And from 1 to 2 the distance is 9. From 3 to 2 the distance is 3 to 2 the distance is 5. From 3 to 4, from 3 to 4 there is no path, right? No direct path. In D0 we create the direct path. So here is no direct path, so the distance is infinity. From 4 to 3, from 4 to 3 there is direct path, so the distance is 1. Likewise we create the overall matrix. So we need to create 5 matrices for this case, right? from D0 to D4, right? So we have already calculated D0. We know how to find D0. So we need to find D1, D2, D3, and D4. For D2, D1 is the best matrix. For D1, D0 is the best matrix. For D3, D2 is the best matrix. And for D4, D3 is the best matrix. Further, Dakshata will explain how to calculate this matrix, and Nishad will show you the formula. Now, D4 will be our final result. So we store D4 for dynamic approach, and this will be our result. And we can find shortest distance from one node to another node, whatever it may be, in D4. So, thank you.
Now we will construct a D1 matrix to find the shortest path between each node via the node 1. So for that, we create a matrix here we take D0 as the base matrix, and the row along 1, the row and column along 1 is considered to be the working row and column, so we write it as it is. And the diagonal should be 0. Now we will see the distance from 2 to 3 from D0 matrix. The distance between 2 to 3 is infinity. For D1, we consider node 1 to be the middle point. So for that, we find the distance from 2 to 1, and then from 1 to 3. From 2 to 1, the distance is 6, and from 1 to 3, the distance is -4. So the new distance is 2, which is less than this infinity. So the value from 2 to 3 is updated to 2. Similarly, from 2 to 4, in D0, 2 to 4, the distance is 2. Now, via 1, 2 to 1 plus 1 to 4. From 2 to 1, the distance is 6, and from 1 to 4, the distance is infinity, so this becomes infinity, which is greater than 2. So we do not update the value and keep it as it is, which is 2. Now from 3 to 2, we have D0 to 2. It is 5. Now 3 to 2 via 1 will be 3 to 1 plus 1 to 2, which gives us 3 to 1 infinity plus 1 to 2 line, which is infinity. This is greater than 5. This is greater than 5. So we do not update the value and keep it as it is. Now from 3 to 4, we have the value infinity. Now via 1, we will get 3 to 1 infinity plus 1 to 4, which is infinity. we get the same value, so we write here infinity. Now from 4 to 2, we have infinity. Now 4 to 2 by 1 will be 4 to 1, 1 to 2. 4 to 1 infinity, 1 to 2, 9. It is infinity, so we write here infinity. Now from 4 to 3, we have 1 via 1. 4 to 1 we have infinity, and 1 to 3 we have -4, which will be equivalent to infinity. This is greater than 1, so we do not update the value and keep 1 as it is. Similarly, we will construct another matrix D2. For this, we will take D1 as the base matrix. In this matrix, we take. For this, we will consider rows and columns corresponding to be the working row and column. So we will write them as it is. And we will write the diagonals as 0. So now we need to fill in the gaps. For this, to find the distance between 1 to 3, we consider from D1, 1 to 3 minus 4. Now, via 2, we will get 1 to 2 plus 2 to 3. 1 to 2, 9 plus 2 to 3, 2, which is 11. This is greater than -4, so we do not update the value of this and we keep it as it is. Similarly, for 1 to 4, we have infinity. Now via 2, we will get 1 to 2 plus 2 to 4, which becomes 1 to 2, 9 plus 2 to 4, 2, which is 11. Which is less than infinity, so we update the value of this with 11. Now similarly, for distance from 3 to 1, in 1, 3 to 1, we have 3 to 1 infinity. Now via 2, we will get 3 to 2 is 5, and 2 to 1 is 6, which is 11. So we update this value as well. Now in the similar way, we find out D3 and D4. For D3, the base matrix will be D2, and rows and columns corresponding to 3 will be the working rows and columns for D3. And similarly for D4, the base matrix will be D3 and the rows and columns of D3 that is corresponding to 4 will be the working rows and columns for D4. Now, so D4 is our final solution, and the values of D4 are further stored because this is a dynamic programming approach.
Up until now, what we've done is we've made a new matrix on the basis of the old ones. So summarizing this process in a single line, what we can do is while updating the matrix, while updating the new matrix, we can take the minimum of the old matrix's same position and the old matrix's same position that go through our vertex K. So this will be the shortcut form of what we've done up until now. And besides this, we will be talking about the program for this Floyd Warshall algorithm. For the program, we can simply just rub out the superscripts. This will be done such that this will be the same array but being updated with the old values. And while going through an array, we should always use 2 for loops. That would be for loop for j and for loop for I. In this way, we go through each and every position in the array, and while updating, we count the vertex that we currently are using another for loop, that will be for loop for k. This is the program for Floyd Warshall's algorithm. And talking about the complexity of this program, since we have 3 for loops, the complexity will be big O of n cube. This would be the complexity of Floyd Warshall's algorithm using this program. That's it for this video. Thank you for watching.